Okay. Oh, no, I can't get out.
Dr. Kujala is not here, so he told me to introduce you the chapter 8, chapter 8 content. Okay, so today I want to go through z-test and the t-test. That's for one sample compared to population. Before class.
Yeah, okay, sure. Let us pray first. Father in heaven, once again, we're thankful for life, for the brain you have given us. We pray that somehow you will allow them to the point in which we can capture the meaning and significance of statistics. As we start this afternoon of academic responsibilities, we pray for Ming, that we will be able to give him the ability to explain to us the chapter he's about to review. We pray in Jesus' name.
Okay, thank you. The chapter 8 discuss. You compare the sample to population, and we compare the sample mean to population mean. The mean of the population, that is mu. So please memorize some symbol. Today I will mention something important. It's better for you to memorize in your textbook. So when we do the test the sample mean to the population mean. The test of null hypothesis. We do the test, but the most important thing, we test the null hypothesis. We can reject or not reject. There are 4 steps. This is very important. On your book, page 185. The first step states the hypothesis. Second step, set up the type 1 error. In this step, more important thing to find the critical. Critical value. The third step compute the test statistic. The last step, you check. You can reject or not reject null hypothesis. Okay, so now, today, I will focus on every step. Do you remember the question last time Dr. Kijai mentioned in the exercise? No?
We were doing column number 1 on page 197. With the hyperactive children?
197? Sorry.
Yes.
197.
With the hyperactive and normal children?
Okay. So in the chapter 8, when you read the question, you must pay attention to the sigma. This sign sigma, that is the standard deviation of the population. Sigma, standard deviation of population. Two situations. If rho is known, if the sigma is known, and another situation, sigma is unknown. The first one you use Z case. The second one you use T case. Okay, so question 1. Do you know the standard deviation of the population? 16. It's better for you to set up the value of every sign. The mu is the mean of the population, sigma, standard deviation of the population. This is the mean, x bar, the mean of sample. S, the standard deviation of the sample. N is the number case, the case number of the sample. So can you tell me the number now? Okay. The mu is 150 because the mean score on the inventory for this population is 150. And it mentioned standard deviation is 16. Sigma is 16. The mean
152.5
152.5.
and 50.1.
Okay. How many cases? 50?
Yeah, sample size.
Okay, sample size 50. So now you know the sigma. Sigma is known. So you use the T test. Okay, the first step, set up the null hypothesis and alternative hypothesis. Null hypothesis, how to pronounce? No. The result we don't want. HA, this is alternative. In your textbook, it's also research. So I remember assignment 5 mentioned about research hypothesis. That is the alternative hypothesis. The result we want. How to set up? You must check the question. Null hypothesis always equal. The equal means there is no difference. No difference, no correlation. No difference, no correlation. You will learn in next chapter correlation test. So H0 should be X bar equal to mu because they are the same. There is no difference. Alternative hypothesis when we check the question, do abnormally hyperactive children differ in creativity? Differ, that is difference. So the mean of sample is different with mu. Okay? Alternative hypothesis, there is two situations. Non-directional and directional. You must check the question. Which situation is non-directional? Different. When you see the word difference, non-directional. Directional, greater, less than, smaller, bigger, etc. You have the direction. Okay, so the symbol in the non-directional, we use not equal. In the directional, if greater, that is bigger than. If less than, that is smaller. So for this question, we set up the hypothesis, non-hypothesis, and the alternative hypothesis. Okay.
In this situation, because it's saying do abnormally hyperactive children differ, not are they greater than or smaller than or less than?
So no direction.
Non-direction.
And memorize. Non-direction, that is two tail. This is most important. Directional, that is one tail. And if the situation is bigger than, you must compare mean bigger than mu. That is right side. Another way, if less than smaller, that is left side. We will use this one in the step 2. Okay. May I erase this one?
No.
No? Okay. Second step here. Set up ABA equilibrium. In the social science, we usually use 0.05. This is important. 0.05 for type 1 error. You will see a level of significance. Type 1 error and the region of rejection. This is the sensitive alpha degree. Alpha degree means the level of significance, type 1 error, and the region of rejection. Can you figure out what is the type 1 error and the type 2 error? You don't need to memorize. You can realize. I give you an example. Now we test the medicine. We want to know the medicine effective or not effective. You don't need to take this note. I only explain. So in this situation, what is non-hypothesis? The results we don't want. Which result you don't want?
Not effective.
Okay. medicine is not effective. Alternative. We want. Yeah, that is effective. Okay, in the real situation, in reality, there are two situations for non-hypothesis. It's real, it's true, or it's not true, that is fails, false, right? False. So if the non-hypothesis is true, the medicine effective or not effective? Good, not effective. So if the non-hypothesis is false, medicine is effective. The same. Researcher do conduct the research, and he will get two results. The first situation, maybe the researcher reject non-hypothesis. This situation, researcher claim the medicine effective or not effective?
If he rejects it, he
When you
thinks it
reject,
is.
okay, the medicine is effective. So the second situation, researcher not reject non-hypothesis. So he or she claim the medicine is not effective. Okay, there are four situations will happen. The one, non-hypothesis is true. Let me see. It's true. And the researcher have the result. Not reject non-hypothesis. What is this situation? Non-hypothesis is true, so medicine is not effective. Medicine is not effective. I use N. Researcher not reject. Researcher not reject. Researcher claim medicine is not effective. Claim and is not effective. So the situation match. In reality, the medicine is not effective, and you conduct the research. You say that is not effective. And so the result is correct. Okay, when non-hypothesis is false, researcher reject non-hypothesis. So non-hypothesis is false. medicine is effective. And the researcher reject the hypothesis here, claim medicine is effective. Is this match? Does it match? So, two situation match. Correct. Okay, the third one. Null hypothesis is true, but researcher reject null hypothesis. What's the situation? Null hypothesis is true. The medicine is not effective, and the researcher claim what's the situation? Reject. Medicine is effective. Doesn't match. Medicine in reality is not effective, but researcher claim not effective. This is error. This is type 1 error. The last situation, null hypothesis is true, null hypothesis is false. And the researcher not reject. So null hypothesis is true. Null hypothesis is false. Medicine is effective. Researcher claim not reject is not effective. So in reality it's effective, but you say it's not effective. So this is error 2. This is type 2. Type 2, we use beta. Type 1, that is alpha. Which error is serious? Type 1. Why?
The person could die. I mean, it's the person taking it, the person could die.
Yeah,
The
that's
first
right.
one, they might get well from placebo.
So this is the reason we don't want make the type 1 error. So type 1 error, smaller is better. Okay, but now you know what is type 1 error. May I erase? I don't
Break it up.
Yeah, you can erase this one. Okay, so the second step, the most important thing, we must check critical value. What is critical value? In the normal distribution, if your type 1 error, where is your type 1 error? If your situation is non-directional, that is 2K. And this area is the alpha. Social science, we say alpha degree 0.05. Memorize. It's very important. Yeah. Okay. So here is because two tail, so this part and this part will become the R bar. So here the area is 0.025. 0.025. Remember, because the sigma, standard deviation of the population, we know the sigma. So now we use t-test. So we use the t table. So you can use table C2 to check this value in this point. If you use tab C2, the larger area is here. This is 0.025, so this is here is 0.075, right? So when you check table C2, the larger area is 0.075. You will get a Z score. This is
Up top is a large piece.
oh.
Table C2.
That will you hide?
Yeah. Did you get this value? 1.96. So here, because normal distribution symmetric, negative 1.96. So we get the critical value, that is positive or negative 1.96. Okay, this is step 2. But yeah, step 2. I think you don't take this one, take note, not this one. You only need to realize the meaning of alpha degree. Okay. So the third one, we compute the test status. This is Z test. So the Z, that is now you compute this one. According to your textbook, the formula of Z test compare sample mean to population mean. That is X bar minus mean divided by standard error. This value you compute, that is test statistic. In your textbook, when you see test statistic, that is the value you compute. When you see critical value, this is according to alpha degree. So alpha degree change, the critical value will change. Okay. And now this is Z test, the Z distribution. In the T test, the critical value will change too. We will mention that later. So, what is the mean? Okay, the first one, I want to let you know this formula meaning. You must know sampling distribution. Sampling distribution. Yeah. Did you take the quiz?
No.
You are lucky. That is in chapter 7. I know the page. Wait. One 165. What is sampling distribution? If this is the population, for instance, for example, Andrews has 4,000 students, right? About 4,000 students. Now you conduct the research. You choose maybe 100. This is the sample. And sample 1, you will get the mean of sample, the standard deviation of sample, right? Then you put back to population and randomly select again. This is sample 2. You will get the sample 2 mean and the standard deviation. The same, you put back, random select, you will get sample 3, sample 4, many times. Do you remember this one? The step. Okay, are you ready? Many times. If I say the X bar, that is the mean of the sample. The mean of sample, so I use the sample n. I don't want you are confused. So this, you will have n1, n2, mean 1, mean 2, mean 3, mean n. Okay. You will get the distribution of these samples. So this distribution called sampling distribution. So when you see the textbook sampling distribution, you must memorize the intermediate. Okay. Many mean. Many samples mean. So 168, page 168, right? No, 165. The characteristic of this sampling distribution, you can get the average of all the mean, right? And you can compute the standard deviation of all the mean, right? The textbook told us the mean of all the mean equal to mu. What is mu? Population mean. Okay. And what is the standard deviation of the sampling distribution? The textbook says standard error. That is the third one. The standard deviation of the distribution is called the standard error. So what is standard error? The standard deviation of the sampling distribution. Now it mentioned the distribution is the sampling distribution in the statement. Okay. It's a very important standard error. The standard deviation of the sampling distribution. Follow me. Standard error, the formula for standard error, that is equal to sigma minus root n. What is n? The case of sample. So for this instance, that is 100. And the sigma is the population standard deviation. Okay.
My question is with that you never really do that.
Yeah,
So that's just a formula?
yeah. I call somebody, they are statistician. They has nothing to do and they figure out.
Right.
In reality, if you do this one, you do many times,
Right.
you will get the mean of all the sample mean. That is equal to mean. Yeah.
But we don't ever really do
We don't ever, we never do this. But you can do this one.
it. And so where do we get those fake numbers?
Okay, let me talk about this one, and you will know why we use this formula. In the before the chapter, maybe chapter 4 or 5, the z-score. You have one data set, the raw score, and you can compute their mean, compute their standard deviation, and you can get every raw score, z-score. What is the z-score formula? Raw score minus mean divided standard deviation. So the second one, x2 minus x5 divided by s. In this situation, how do you get the z-score of the mean? The first one, mean 1 minus the mean of mean divided the standard deviation of the sample distribution. This is the second one. So the same, right? No problem? Now you must consider the mean, the sample's mean as raw score. Like this situation you learned before. We check the first one. What is the M1? That is the mean of the sample 1. What is the mean of the mean? Mean. What is the standard deviation of the sampling distribution? Standard error. Is this the same? This is the same as the formula. So when we compare the sample mean to population mean, we do the z-score transformation. Okay?
Can you say that one more time?
Okay. You will get many mean, sample mean. This is sampling distribution. Okay. What is the average in the sampling distribution? The mean of the mean. That is equal to mu. Do you follow me?
It's the mean of the population.
Yep. So the mean of all the sample mean equal to population mean. That is mu.
So what you're saying basically is that when we're doing this, it's basically the same thing as taking a raw score and putting it into a standard score, except for now the mean is the raw score and we're putting it into a standard mean. And
Yeah.
then our standard deviation is the standard error of the estimate.
You are right.
So it's all the same thing, except
The
for
same
now we're
thing.
just comparing means to.
Yeah, you got it.
You have to remember all these words.
Could you repeat it again? the same situation as you learned before. Now the standard deviation becomes standard error. The raw score becomes the mean of sample. And this mean is the mean of mean, that is mu, the population mean. That's it. And you will ask me why we use this score. It's related to test null hypothesis. In your book, on the beginning of the chapter 8, 175, you will see this figure. At last, there are two differences, larger difference and a large difference and a small difference. What is the difference? When you compute this one, the z-score in the center, that is 0, right? And you get the z-score when you compute, that's equal to 1. What does 1 mean? Your point, from your point to the mean, that is 1 standard deviation. Okay. When you get z-score equal to 3, you have 3 standard deviation distance. So the z-score 3 is far away than z-score 1, right? When you compute, this is test statistic. It is close to the mean. The z-score of mean, that is 0. If you compute, you get 1. Okay, maybe this is 1 standard error distance. Okay, if you get 3, you get 3 standard error distance. So if you get higher z-score, you will farther, not farther, more far, right? More far. Okay. The question is, what is criterion for you to judge small difference and the large difference? The alpha degree. So when you set up the 0.05, you will get the critical value 0.96. So our criterion is 0.96. If your z-score more than 1.96, you can reject the null hypothesis. This is the figure. And the reason why we use the z-test. Okay? Anyway, if I compute, you can understand more.
Can I ask a question?
Okay?
I noticed we're talking about comparing means. I'm wondering, you say if our z-score is greater than 1.96, then we can reject it. But when we were talking about the standard score, we actually had
Negative.
So we had to do negative, but
The textbook uses this word exceed.
right.
So when you two-tail, you will get positive and negative 1.96. So if your value is 2,
Right.
you exceed. If your value is negative 3, you exceed 2.
But with the
Because
raw,
you exceed negative 1.96.
right.
So it falls into rejection area.
Correct. But with the raw score formula, when we had a raw score and we wanted to figure out where it was, we actually had to multiply that score times 1.96. Well, this is already,
What do you mean raw score?
well, I don't know. I'm trying to compare it to the normal distribution where we were talking about earlier. It seems like when we when we came up with 1.96, we had to do some multiplication to figure out.
You are talking about a raw score, right?
Right.
And,
Yes, I think so.
We will use this concept in the confidence interval.
Right.
So now you
Okay.
don't.
So, but we're still gonna do that with this right here then? Or not?
This is in step 4.
Okay, I'm sorry. I'm not
Yeah, it's
trying to do
okay.
that. I'm sorry.
So now we can compute the z-score. What is the mean of the sample? Minor mu 150. Okay, what is the standard error? Standard error 16 over root 50. Calculated 262.
263, really? 2.263.
Okay, 2.263. So now we put into 2.263. How much is it?
Oh, no, I'm sorry.
You wanted the
That's
square
the
root,
total.
the square root of 50?
I think this is 7 point,
Yes, I'm sorry, 7.071.
and 16 over 7 point, blah, blah, blah. How much?
That was the 2.262.
Okay, yeah, you are right. So you put standard error 2.263. How much is one?
The Z total,
Yeah,
1.105.
1.105. Okay, the last step. Now we check it can reject or not reject. Because test statistic. How much? 1.105. Doesn't exceed critical value. How much critical value?
1.96.
This is the same meaning. The test statistic doesn't fall into rejection area, or you can say region of rejection. Why? Where is the 1.105 here? This area is not rejection area. This is rejection area. So you cannot reject null hypothesis. We can't reject null hypothesis. So where is our null hypothesis? Here. We cannot reject. We must accept. They are the same. The mean of sample is the same as the mean. Okay.
Ming,
Mm-hmm.
why is it that in the answers, they give kind of a different answer
Really?
as to the result? The result of that operation, they give
They reject.
0, no, over here in the book, the answer is 0.90.
Wow. 2.5.
2.5
And
divided.
where is the denominator? This is 2.5. Denominator how much?
2.26.
2.26. Yeah, the same. What is the result?
I guess the book is wrong. I think you're right, but when I was doing this exercise, I was confused.
our value is correct, it is wrong. If you use that value, you cannot reject neither. You cannot reject. So the result must be the same. We cannot reject null hypothesis. Any question? No?
Ming, I have a question on step number 1.
Number one, here.
When to decide whether the alternative hypothesis is bigger or not equal or
You must check the
greater.
question. Question will ask you, the sample mean is greater than population mean. You must use this sign.
Question 2 of the test. The population mean for the Lyell scale is known to be this. So using the appropriate procedure to determine the children under stress. So I don't know whether this should be non-equal.
Okay, your assignment 5, question 2. But you want higher than expected.
So that's directional.
Yeah, that's a direction. Higher than you use this symbol.
And then you use a one-tailed test?
Okay, let me do one tail test.
Yes, please.
Now, I have a question.
Okay,
Regarding
one.
number 2, it doesn't give us the population mean.
Right,
So I.
Number 2?
A t-test.
Okay, I must use t-test.
right,
I didn't illustrate number 2, right?
Right, no, you didn't. And
You
I
did
have a
not.
question on when you have, look at the chart, the table C3 for the critical values, because once they get larger, it goes from like 30 to 40, so if it's 38, you use the 40 instead. Okay, for the
Table
level of
C3.
significance, yeah, so right here, so actually the DF is, if it's,
TF is n minus 1.
yeah, if it's like 38, would you use the number for 40 because it's closer to
No, no, no.
40 than 30?
The n is 38.
Right.
You must use 37.
Yeah.
But the
there
DF isn't
isn't.
included in the
The
table.
DF, it's
Which-
not
which
included.
DF?
See, in here, the DF equals 35.
Yep, and it's between
And it's
30 and
between
40.
30 and 40, so what would you use? It'd be in the one tail.
I use
Level of
40.
significance, I use 40. That's what I was.
It's better to use the bigger one, larger one. And, okay, wait a moment.
Okay.
What's the test statistic you have?
I'm opening it up right now, I don't know.
What do you want, what do you ask?
What is your t-value?
My t-value equals 1.2.
So it's smaller, it's no matter use the 35 or 40.
Okay.
Your value that is smaller than that, right? So can you reject or not reject? You cannot reject because small. Your t-value is small. Your t-value doesn't exceed.
No, it didn't, yeah.
Doesn't exceed.
Okay.
Okay. Now let me do the directional or t-test.
And then I have a question after that about how to do the significance interval for that afterwards. I don't, we didn't
Oh,
do the one.
confidence interval,
The
right?
confidence interval, yeah.
We didn't really go over that.
No, we didn't, but we've been doing it over.
It's a problem because
Beforehand.
the same range on the D2L, the same content for chapter 8, Dr. Kijai mentioned confidence interval and the effect size. That means maybe he used another textbook before, so the range include confidence interval. But that's easy. Then
For who? Easy for who?
For you, that's very easy. Okay, we compute this confidence interval first. What is the confidence interval? Here, this part, we do the test. We test. But confidence interval, we do the estimate. How to pronounce estimate, right?
Estimate.
Estimate.
Yeah.
We estimate what? Because usually in reality, we only get sample mean. So we use sample mean to estimate population mean. What is the meaning? We can check the confidence interval formula. That is the
And I have a question on this. Why do you have to check? Yeah, I don't see why you use the same confidence interval formula for a two-tailed and a one-tailed.
our confidence interval always two-tailed. If you use the concept of tail, why?
Well, I understand that, but because number two, you're doing a one-tail because you're using, it's directional.
Okay, one tail, that is for testing.
Right, okay.
Now we do the estimate. Estimate always two-tailed because we want the center.
Okay, I get it now.
In the middle, in the confidence interval, this situation, the middle of the distribution, that is the mean of the sample. And these two parts is the critical value. And they construct a range. This range is the CI. So if you set up 95% CI, that means this area is 0.95. When you check the table, you will get here is 1.96, negative 1.96, because the situation is the same two-tailed test.
So what you're saying is you're 95% confident.
Yeah,
Your score falls in
95%.
there, that if your score falls within that range, you're 95% confident that it is a match to the population.
The population mean will fall into this range. So now you must compute the raw score. Okay, because in the center, that is 0. If you use this score, do you remember the raw score formula? Raw score equals Z times S plus mean. So the confidence interval formula, this is negative 3 here, negative 3 times S, because we know the sigma, standard deviation of population, so we must use standard error here in the plus the mean. This one. This is the formula. And this formula is like the raw score formula. But pay attention, the standard deviation, you must use standard error. Okay? Okay, no problem. Thank you. So what is the CI range for this example?
10.
It's supposed to be sigma x bar on both sides, right?
Oh yeah, sorry.
No, it's just.
In the t-test, it's become different. I will mention it. Okay, the negative z, this is critical value for 95%. So that is negative 1.96 times. What is standard error? here, center here. 2.263. The mean of sample. Here, that is positive 1.96. This is a critical value, Z value for 95%. Times standard error plus mean. Can you give me the value?
On the left, 148.06.
148.06. How about this time?
156.94.
156.94.
Yes.
This is your answer. What is this answer? You will have 95% chance the mean fall into this range. This is the confidence interval mean. You will have 95%. The population mean fall into 148 to 156, this range. Okay, did you follow me? The last one, effect size.